Electronic. Yeah.
I see. Good.
So everything is okay in
It's okay. Yeah,
right.
it's okay. Yeah. Still work at home, yeah, mainly.
Yeah.
I think you go to Kumamoto every day, right?
Every day, yes.
Yeah, go back.
In
All
my
from there.
case, although we are allowed to work at home
Yeah.
or maybe work from home, right? But I cannot work from home actually. I cannot work. I cannot
Yeah.
concentrate. Anyway, I
Understand. Yeah.
I always come to the university. Yeah.
That's the way.
How about in Bali? Oh yes, Dr. City is here.
Hello. Hi, Dr. City. How are you doing?
Dr.
How about
City,
you? Yes.
thank you so much for the testimonial video. I'm sorry to make you busier.
It's okay. After that, I have to flew to Lamongan. I think it's about 3 hour driving from Surabaya to Lamongan to have like public services.
I see.
Hello, Professor Suttichai Armando. When we can have an offline meeting?
We should.
Offline. Yeah, why not? Yeah.
We should.
I want to go somewhere else, not in Thailand.
Dr. City, it's your turn actually.
Yes. Actually, I already discussed with Maria.
Please arrange it next academic year. I think we can visit ITS already.
Yes, yeah. I hope.
If this pandemic situation gets better. Right.
How about in Thailand and Japan, Professor?
Thailand.
Yes.
Thailand, let's say we open our country already, but
yes.
With limitation. So the one who will come need to get the full vaccinated and so on. Yeah. So need to have some proof, and when to get in need to have ATK checking, something like that. Yeah. But it should be a good development. Yeah.
You have to quarantine something like that, Professor. For example, if foreigner come to Indonesia, they have to stay in one place for quarantine at least 5 days, or before it's up to 8 days. But right now, I think it's about 5 days. How about in Thailand?
In Thailand, I think it should be shorter. Yeah, maybe just 1 day. Yeah. 1 day to check. But I think it will change. Yeah. I don't know, even though sometimes people in Thailand, we say that maybe next year we will close again if the number of cases getting higher. So this is something unpredictable. Let's see.
Yes. In Indonesia, if I visit to village, something like that, for example, like last time, as I mentioned, I have to go to Lamongan. So nobody wear mask.
Oh, I see. And the number of cases increased. Yeah.
Not yet. In village, they mentioned, "Oh, Corona afraid of us."
Good.
Only in the city, people still wear masks, but in the village, every time I went to, for example, like in my hometown or other village, it's really people wear masks. So that's why when last time I visit students have real work in the village together with the society, some students say, "Oh, we are trying to get mingle with the society, so we are like them, so we didn't wear masks." So I say, "No, you cannot do like that."
But people feel that we are the same. Yeah. So mask off. Yeah. That's the way.
By the way, Professor Suttichai, if you don't mind, can we record a video of this lecture for ITS students?
No problem. No problem at all.
Thank you so much.
Can you
Because
allow me to share the screen? Right
yes,
now,
yes,
I try to share, but
okay. Thank you.
disable me. Yeah.
Because some of the students of ITS cannot attend on time because of the Friday prayers. So that's
I see.
for that reason, we are taking a video of the lecture. I hope it's okay with you. Okay. I think Professor Suttichai, I think you can share this slide. Huh?
I'll share it now. Okay, and can you see my screen?
Yes.
Yes.
Perfect.
Great.
But Professor Suttichai, before your lecture for today, please allow me to announce something to the students regarding the schedule.
Sure.
So it's overlapping the Sakura Science and your biomass utilization lecture. So
yeah.
Okay. Thank you so much.
Thank you.
It's working. Good.
Great. Now I log in with two screen, so that the other screen I can see students.
All right.
Otherwise, I can only see the PowerPoint. Yeah.
I see. Also, you have two Zoom account. Is that right?
No. Same account.
Not the same account.
Same account.
How that's
It's
possible?
okay.
Oh, really?
Yeah. Somehow, I don't know, but I try. It works.
Same device, Professor?
Well, I think
same account.
same
Yeah.
account.
But
I think
the other one I use in iPad.
I see.
Yeah.
All right. Probably it depends on the license that you have.
Probably, yeah.
Yeah. So the license that you are using in the university here, Kumamoto University won't allow two meetings at the same time. But sometimes I need to attend two meetings at the same time. So I use my Hotmail account. So
yeah.
We are
That's the way.
accounts.
Just try on and on.
Right.
So usually during the lecture, most students just turn off the camera. Am I understanding correctly?
Yes. To decrease data usage.
I see. Okay.
For the
So maybe
students, it's also right. It's also
I
good
don't need
for
to screen now. Yeah. So I leave the meeting on the other account.
because it's like good for the students, especially if they are like like they pay via data usage, so to minimize, right?
Understandable. Okay. Same in Thailand as well. When I did my lecture, most of the students just turn off
the camera.
Even sometimes I encourage, so please turn on. I want to talk to people, not just on the screen.
Exactly. Very difficult because you're like talking to black screen and then the names and you don't know the reactions of the students. It's quite difficult doing it online. While you do it face to face or offline, you know the reaction of the students, so you can actually adjust how you're going to the approach to your lecture. But oh my god, anyway. I hope we can do face-to-face lectures soon.
Yeah,
we actually shifted to face-to-face already. Our vice president for academics encouraged us to do face-to-face, but somehow the students got used to these online classes, so they prefer. When I made a survey to my one of my classes having 89 students, 75% of the students
online
preferred online. Preferred online. Oh my god! So because they got used to it already.
Yeah, never mind. So most of the students who attend will be from Japan and also from Indonesia. Is that right?
For the perspectives in biomass class, yes. For
I couldn't hear you.
Kumamoto University and also ITS. There are
Just a moment.
from ITS, there are about 24 students, and from Kumamoto University, around 11 students joining the class. But for today, we also have Sakura Science participants. So it will be a very big class today. Okay. Not only participants, but their supervisors are also here joining your lecture. Yes, I think Ian Dominic from University of San Carlos is here. Dr. Ian Dominic, thank you for attending this lecture today. And welcome to Sakura Science again.
Yeah, the topic is quite interesting, so that's why.
Thank you. Thank you so much.
Yeah, thank you.
Dr. Ian Dominic Tabanyag is from the University of San Carlos, considered to be one of the top private universities in the actually the top private university in the science region. And he is also specializing in chemical engineering.
Good. Yeah. By the way, Prof. Suttichai, please remind me if I tend to exceed the time limit.
Okay.
I'm not so sure if I could control the time well or not. Don't hesitate to interrupt me.
Okay.
Okay. And can I come back in a minute?
Sure. Dr. Siti, would you like to announce something to your students before we start with the lecture? Or... All right.
Okay, good morning, everyone. This is special for Kumamoto University students and also ITS students that we have a final report and presentation that you have to submit next week. The exact time is 25 November 2021, 5 p.m. either in Japan Standard Time or Indonesia Standard Time. And then I already put in my classroom, and I'm sure Professor Kitain also already posted in a Moodle. So talking about the content, each group must write 1,000 word essay about any topic in perspective on biomass utilization. The format also we already posted in my classroom or Moodle. And don't forget, you have to discuss with your group team and then submit it before 25 November the final report, and also presentation. The duration of a video, at least 3 minutes. And in the video, it's already covered about the problem identification, data collected, figure and table, analysis and arguments. And don't forget to put some creativity, the quality of media. And then the most important, you can convey your message in your report into 3 minutes video. If you have any other question, you can raise your hand before we start this class in collaboration with Sakura Science Program in another 2 minutes. Professor Kitain, you want to add some information or comment regarding the final?
Thank you so much, Dr. Siti, for announcing the final presentation and then the final report. The details actually are already posted in Moodle for our Kumamoto University students. So please check the details in the Moodle page for the class. Okay, so we are looking forward for your presentation next week, but please submit the presentation by the 25th, all right? 25th, but you are going to make a presentation on the 26th, that's a Friday, same time as we have now, all right? Okay, so it's already 12:55, and welcome once again to the Sakura Science participants. Welcome. This will be the final day for the Sakura Science activities for this week. And you will listen to the lecture of Professor Suttichai Assabumrungrat on the topic Process Systems Engineering for Enabling Development of Biocircular Green Economy. Let me introduce Professor Suttichai. He is actually a very good friend of mine since I first met him at Nagoya University. That was around 2000, more than 20 years ago, if my memory serves me right, Professor Suttichai. And then, yeah, since then, we continue this, like connection, collaboration. We can never tell. For the Sakura Science participants attending this exchange program, probably after about 10 or 20 years, you will also have the same collaboration that we are having with Professor Suttichai and also Dr. Siti of ITS. So, well, Professor Suttichai obtained his PhD in chemical engineering from Imperial College London, and also his Master of Science also in chemical engineering. From 2006, he became professor of Chulalongkorn University. He got many awards, of course, and the most notable one is the NASDA Chair Professor from the Crown Property Bureau Foundation. And he is now the director of BCG Tech, all right? And I think Professor Suttichai will explain to us in detail what BCG Tech is, all right? Well, without much further ado, let us all welcome Professor Suttichai Assabumrungrat of Chulalongkorn University, the top university in Thailand. Professor Suttichai, please.
Thank you very much. But before I start, may I remind you that you would like to record the talk. So you can record the talk today.
Okay.
All right.
Thank you.
Recording
Professor.
in progress.
Okay. Can you see my screen? Okay, thank you. So first of all, I would like to thank Professor Kitai and Dr. Siti for very kind invitation and for the very good opportunity for me to join the perspectives on biomass utilization and also to join the Sakura Science Exchange Program. I think the program and also the course are very good, very interesting, and provide a very good opportunity for many people from all over the world to join. And as Professor Kitai mentioned, that it is very important that people should know and connect and have the work or research together so we can do something more impactful, not only to our countries, but to the world. So, okay. So today, let's me move to my presentation. Okay. So the topic that I would like to share with we all of us here is on the process system engineering for enabling development of biocircular green or BCG economy. So this one is actually on the concept of something more sustainable, biocircular and green. Okay. I first of all would like to introduce a little bit about my organization. I am from Chulalongkorn University. Uh, Maybe some people don't know what is Chulalongkorn University. Somehow it is the oldest university in Thailand. Today we celebrate 104 years already. So based on our good location, we are situated in the city center of Bangkok. So we are very welcome you all. If you have any opportunity to join to come to Bangkok, you are welcome to visit our university. And as I mentioned to you that we are the oldest university, so somehow we are a kind of comprehensive university. So we have all discipline, uh, engineering, art, science, social science, something like that. So you can find any discipline in our university. And for the vision of our university, we say that we would like to produce leaders who create knowledge and innovation for sustainable society. So this is our vision of our university. Okay, and somehow, even though we are top ranked in Thailand, but we still need to work a lot more in order to be in the world or international platform. So this is the rank that according to different subject area, somehow we did quite well in some certain discipline, but there are a lot to work on, especially on the engineering and technology. Somehow we rank 244, but our target we try to be top 100. So a lot more to go on, but that's the way we have to strive for. I am working in Center of Excellence on Catalysis and Catalytic Reaction Engineering. So with this one, you can see that my background is more or less on Catalysis and Catalytic Reaction Engineering. But the topic that I mentioned to you earlier is on the process system engineering. So somehow I will tell you later that why I get interested in this field for the process system engineering. And I consider this field is very important to make it possible for the BCG economy. Okay, and in our center, we have 10 faculty members. And if we look at the research area, we focus on, as I mentioned to you, that catalysis and reaction engineer. So we focus mainly on many type of reaction, but in the past, more related to petroleum, petrochemical feedstock. But in the past 4 or 5 years ago, we focused more on the biomass. So this is to follow the trend of the biorefinery. Okay, so I would like to start on the outline of my talk today that I would like to tell you on the 3 main topics. The first one is on why bio-circular green economy. And the second one is what can process system engineering or PSE contribute to the BCG? And the third one, I would like to give you some example on the pulp and paper industry. How would the development on the BCG concept for applicable for the pulp and paper industry? So let's move to the first topic, why BCG? So this slide, I think, to give you an overview that somehow over 160 years ago, we have been developing based on the major resource of the fossil, such as the petroleum, natural gas, and coal. And there are a big development, especially after the World War II. And if you look at this slide, it shows that a number of prominent scientists who really make a big change to the world. For example, if you are familiar with the Haber-Bosch process, both of them received the Nobel Prize, and they developed the ammonia synthesis process. And based on the ammonia synthesis process, let's say a number of people in the world growth dramatically because there is no limitation on the food supply with the urea fertilizer. So the agriculture crops quite easy to produce. And some other example like the cigarette. If you are in the area of the polymerization of polymer, cigarette are two prominent scientists who developed the cigarette catalyst that can make a good property of polymer. And this one on the right hand side, Fischer-Tropsch, also another famous scientist who developed the Fischer-Tropsch synthesis reaction. This one you can use the syngas, which is the main composition of hydrogen and carbon monoxide. It can be used for synthesis of biofuel, methanol, and so on. So this is something that we have been developed for over the past 150 years. And this slide, you can see some example that based on the fossil-based feedstock, there are a number of, let's say, the commodity chemicals and also some final end products. These are just an example. I trust that they are more complicated than this one. And this is the past 150 years that we have been working for. But if you look at this slide, it shows the top global risks by impact. This is the result from the survey of the World Economic Forum. And if you look at the recent years on the 2021, you can see that the top risks surely is the infectious disease like COVID. But you can see that the second rank is on the climate action failure, biodiversity, natural resource crisis, human environmental damage, something like that. And if you look at the past, like the 2020, climate change comes first, biodiversity, extreme weather, water crisis, something like that. So this is some of the concern that after we develop our economy based on the fossil fuels, you can see that it caused many problems. And if you look at this slide, it is more related to the past COP26, the global warming. So you can see that this is the amount of CO2 released to the environment. You can see that during 1900, the emission is with this amount about 2 billion tons of CO2. But for the year 2018, you can see that the amount of the CO2 emission is about 20 times higher. So this is the major reason for the global warming. And there are a number of more problems, like this one is on the plastic waste. You can see that this show the plastic waste, the amount produced. You can look at the scale of the big circle. And for the mismanagement, you can see the fraction in red. In Thailand, somehow we are not doing quite well for the plastic waste management, but they are all over the world as well. So these are some examples that we found. And also there are a number of other problems like the global air quality. Thailand also faced a big problem for this one. And now during the winter time, we are going to have the big problem again for the PM particulate particle. The level is quite high. So this is another problem. But as I mentioned to you about the problem, somehow this time we are quite lucky that the UN has initiated SDG. So this is the target for all over the world to be achieved by 2030. And there are a number of issues, 17 SDG target that we have to try to achieve this one. Okay, so based on the SDG, there are a number of action, I think, all over the world. And Thailand also try to achieve the SDG target as well. And this is our former minister who play a very important role on the BCG model. BCG, I think you can get some idea about B. It stands for the bioeconomy. C stands for the circular economy, and G stands for the green economy. So this one, let's say somehow some other people try to think separately about this individual economy. But for this minister, he considered that all need to be considered all together. So if we get our economy achieve the BCG model, it should be able to offer opportunity for economic prosperity, raising human social well-being, and also offer the good environmental protection as well. So I would like to touch a little bit about the detail about the BCG, even though many people would be familiar, especially the one who joined the perspective on biomass utilization. I think you must be very familiar with the bioeconomy. We try to replace the fossil feedstock with the biomass or something more renewable. And it is possible because we used to do it in the past, maybe more than 2,000 years ago. We mainly based on the biomass. And then suddenly we changed to fossil. But now we are going back again. So it is possible. And with the biomass feedstock, everything should be a lot better and more sustainable. Okay, so we go to the second one. This is the circular economy. And I trust that we are familiar with our current economy, which is based on the linear economy, something we call linear economy. The, the, the way we do is to take the resource from maybe natural resource, and then we make product, and finally end it with the waste to dispose it. And the circular economy, we try to close the loop. So it is called circular economy. So try to reuse like this. If we go to the circular economy, be able to be dependent on the import raw material. Also, with the metal that caused by resource extraction, and also be less to so this is the that together in the domain of the PCC. Thing that we try to use the PCC model as the engine for development of our country, and based on the how Thailand and some many countries will to the service via Indonesia, Macau, Vietnam. We are keen of this opportunity for us to use it in the useful and knowable. This some studies for land I could the
あ、俺もうスイッチないや。何やったん？もうスイッチダメだ。
the gas export and we for export and second given the contribution about and also this is second first should be palm oil. We also have the resource from palm oil and the as the export in the world. Yeah. So this is somehow opportunity as the other of the resource and the biofuel do very well on the background. Maybe biofuel in that we use this based on now and somehow it the second it as the biofuel producer in the world as top biofuel producer. So this is proof that we have been doing quite well of the bioeconomy. Somehow actually has to not only as you know, there are a number of opportunities for bio product fuel can go to the bio feed extra. There are plenty of opportunity, but it's not easy. Big challenge and we have from the easy economy to easy economy. It's not easy just put the biomass feed in or you can only use the somehow cannot just replace it with the somehow there are big change of in the time of the stock and see what when they are hydrocarbon like the crude oil or petroleum. It consists of three main components: cellulose, and lignin. The different molecules. So yes, the treatment process, the reaction process would be changed. So this is something we have to be aware. We look at the past during the past
Professor Suttichai, sorry to interrupt, but the voice is a little bit choppy, maybe due to bad connection.
and I just stop my video if you don't mind. Okay.
Okay, yes, please.
This way. Okay.
Can we try it again, Prof. Suttichai?
Hello.
All
Can
right,
you hear?
it's better this time.
Okay. So let me continue. Can you hear me properly?
Better, but a little bit choppy still. Would you, okay, would you like to try it again, Prof?
Can you hear me now?
Yes, perfect now.
Hello? Okay,
Yes,
okay.
perfect. Thank you so much.
Let me turn on my camera. Should be better. Would to on about to you earlier, not that easy to change fossil economy, BCG, let's say for the feedstock petroleum to the not that easy to change. Past experience to year and with the form skill that can be useful for development of the economy. So for the reactor or the equipment, I trust that they are still the same, even though we change the feedstock, the crude oil to still the we still need a power, and also in the design of the action of the reactor, we still need to know the kinetic, even though the stock or chemical is different, but we still need to know the kinetics of the reactor to design to of the reactor. So the past experience is still useful for the development of BCG economy. Something that's still good, and we trust that past experience can the BCG bigger. Okay, and this just to show you that it's possible that can make it can by the system. So maybe we are just a small detail, but we can make everything possible. But we need to work together, align the system together. Okay. So I would like to do the second topic, the hand process MHP. It's the that's important. And as I told you earlier, that I try to interest to process system engineering, because this is very important to make this. Actually, when we change feedstock, there are number of possible process would the architect that we would like to have in order to the best solution. The process engineering is needed in order to make the right decision. Come to the I want to show you this. This is Dr. Roger Sargent. He is from Imperial College. This guy is considered to be the father of the PhD. Somehow, the PhD is a rather new print 50 years ago, and Professor named that is concerned the understanding and development of system for the design, control, and operation process. So this is something that the area which is important to make the decision by developing a systematic procedure so that we get the right decision. And for this one is rather limited to the chemical system. The Prof and also father of the is of the Sargent, and he defined for the area that this area is concerned with the improvement of decision-making processes creation, operation of chemical supply chain. So this you can see that when the chemical process now back to all the supply chain to get involved, and you can see that it deals commonly manufacturer distribution of chemical products in the context of many conflicting goals. So there are a number of scale and of scale, either short or small time scale of molecule, the next or even to country to the world as well. So this is the area that very important. Especially we would like to do the BCG economy. And in the slide is so that for the involve a number of issues like supply chain optimization, data analysis, mathematical models, tools development. So for the PSE that can make contribution to design the new BCG. Okay, and in just show some issues that they need to be aware. For example, this is the one for the circular economy. So a number of for example, on the environment, on the economic benefit, and also for resource scarcity, something like that. And you can see that the scope consider the for the landfill, emission, so on. So a number of issues to be addressed in order to for the BCG economy. And this to show more idea that on the involve a number of different features that can be used for product. And I think you know, even we change the biomass feedstock, change the petroleum feedstock to biomass, that it is not necessarily that it should be the same chemical. It needs to be the polyethylene or it needs to be the polypropylene. Actually, it's not it, as long as the is okay. So this is ability that for mass you can use it as the two different building of material and to the chemical that provide say functional property. Okay. So with mass it can involve different features like the carbohydrate consists of starch, cellulose, can be lignin, lipid. After you a big to different chemical pharma, this opportunity is and this one is also an example for the as I mentioned cellulose can be produced some building material like the follow lactic acid, ethanol, and I material can be used to put in this to more one. That's never mind. So the begin we use to print. We are not quite familiar. This vanillin, vanillic acid can get familiar with the name, but many of that we are familiar. See that the molecular are the one that we are to. So it's something that not easy to make the BCG, but well, if we really try to use the past knowledge, make it. In this slide, I want to idea that we need to be aware of expectation on the economic, mostly consider, but to take into account what also the social. There are many issues to consider, like the capital efficiency, optimization, margin improvement, those return for the social issues about the human rights, the risk relationship. So they have to think in order to our finally or BCG economy, like the convention for the environment, we need clean water, zero waste, like that. The PS then try to develop another approach, consider various issues together, something like the analysis, like the benefit, eco efficiency, analysis, accounting, sustainability impact assessment is something in the area for consider for the field of consider like the impact assessment, assessment, the sustainability impact assessment, also for you see that a number of lifestyle. I think this one family, and it is to show you that there are a number of development in terms of different aspects like team management. I think one is something that we have been taken into account for a long time already. But for FCA, first development is in about 1980. So make advancement. I think in 1997, somehow FCA has been incorporated. So this is like the in the economic efficiency is solid process or the design a number of steps like the process design, and in the process design it will need to consider the simulation in order to either suit process what should be the equipment necessary or the to say for the reaction something like that, and also on the process to make analysis also in order to get the right process or process system involved that I mentioned to you earlier. During the past 45 years there are number of software have been developed in order to design the right to get the right process. This one in engineering, you must be familiar with the Aspen Plus, be familiar with you may be familiar with reforms, something like this. Okay. Were designed in order specification, and condition, things like the speed to get the final answer, cost to get the software that get.
Professor Suttichai, may I interrupt you once again?
So the signal turned bad again, right?
Yeah, it's still choppy.
Sorry
It's
for
okay.
internet.
Yeah,
Yeah.
something wrong with the internet connection, but it's all right. Please continue. I hope the students could understand. All right. So please continue. Yeah.
Sorry. So if you come to the state that for the process evaluation, many considerations that like the energy efficient, also the economic, how in practice they incorporate this model process economic analyzer. So you can use to get a quick look about the process that you use for the key area, try to get convenient to use. Obviously, you need to pay for and I need to like this on environment. For the environment, there are consideration like the LCA and LCA. They also consider the modeling for the consideration like for the gate that is the aspect of it. It's just input. Get to get is to input and the process, and it can cover the cradle to grade, cradle to grade, cradle to cradle, and in detail you can find out. And this is just to show you if you consider this one, there are that you can use to see it, to take into account the different boundary as well. And this is another issue. Process. There are a number possible as to need to take into account of the environmental safety. This is also important because the process needs to be for operation, doesn't cause any harm to your workers, and there are software that can use this one. And another aspect you would like to create process, you can use the exercise as well, and exercise all focus of the process, the equipment to the operation they perform critical with the exergy analysis. It incorporates the step of control the environmental as well. Or into this one, as I mentioned, there are a number of possible tools used in order to calculate the value, either as energy analysis. So you can just your convenient aspect to calculate, not only get the conventional energy data or mass data.
Recording stopped.
You can get to know the energy as well. Okay. And this is some more information in depth of the exergy analysis that it can be incorporated to consider in another topic. So do detail on this one. This is to show you they try to incorporate more consideration in order to cover the more whole range, like the energy analysis, ex economic, for environmental analysis, something like this. And this is detail. Not get it. Or if you are interested, I think you can find most literature. So I would like to do the will address to you is on an example for the pulp and paper industry. This one thing that I also to the way we can incorporate the concept of PCT of the existing industry. And the industry we select is on the pulp industry. Somehow
Recording
is
in
also
progress.
is also very important and get some challenge as we for the paper industry. Somehow the development of the EG, so the demand use of the paper is decreasing, but somehow a number of pulp and paper industry are still need to survive. This is the reason that we select this pulp industry. This is the work my PhD student with the collaboration with Professor Rafiq Ghani. I would like to address a little bit about Professor Rafiq Ghani. He is professor at the University of Denmark, Technical University of Denmark. Somehow he retired. He already opened, let's say, found a company called Early and in the PS area. Okay, so I have to move on why we consider the pulp and paper industry to show you the opportunity that use of the PCT to play with the pulp and paper industry for sustainable development. For one, the pulp and paper industry, somehow it will recognize low efficiency of raw material and energy utilization. So we don't see big development in process at all. Recently, no big innovation on the pulp and paper industry. Somehow it's something like dead development. So they offer quite low margin and stability. So these are that we can incorporate the pulp and paper industry. The biology. We know that raw material for the and paper production is biomass, like the sugarcane is able to use the waste from the pulp and paper industry as paper. The main component still have lignin and hemicellulose, and they can be used for producing products. So is we call the paper industry polymer to because it's for alone bio it's not quite good. Somehow it is quite costly, high capital cost for the treatment, and so that we try to consider is to integrated biorefinery. So integrate biorefinery the pulp and paper industry, and that it offer more opportunity for the new revenue generation. You can see that not only paper can get biomaterial, you can get biochemical and fuel well. So it your pulp and paper company to more variety of possible, and it also offers more opportunity utilize of gas in the process. So the be and it can be low efficiency of energy. So this is the thing that benefit the great biorefinery pulp and paper industry. Question that number of possible biomass and fuel should be the simple. And also another what possible processing route in order to into your entire product that you like to have, like the cynic acid, also many possible to make it. So to develop some systematic methodology with support of computers to help you design process. So and also we work together to propose the systematic methodology in order to design the integrated energy process for the pen and paper industry. Let me go. Objective is to synthesize and analyze optimum integrated network in existing pen and paper industry, sustainable alternatives using systematic methodology and to use here. So I will do the systematic methodology. We propose the T-step method in the synthesis design and operation. So I will go to detail. The synthesis method of information of product possible route we for we call the superstructure of the identifying the possible product. This P1, P2, P3. So we identify the possible raw material, as I mentioned, for power.
Recording stopped.
Sugar cane, you can use eucalyptus and a number of processing route, and it many steps, and each step you can use different mass
Recording
treatment.
in progress.
You can use the you can use acid hydrolysis or base hydrolysis, something like that whatsoever. First, we generate the superstructure of the product and processing route, and after that, involve the super optimization. So this you that the process step you need to need, and it depends on how good you find it. If you can find really precise information for you, so if you the detailed information that will be for you getting the good superstructure, something like that. This is to show you that from the super it is that we need to gather all the information in the program that use called Super O to gather all the possible product and possible processing step food or this software. This interface we call GAM is a very useful software optimization. This collection we have the super, and this is simple that for the structure generation it can be like after we get the super structure, we can go to the organization. You can get the best product and best food for you, and example for the and paper industry. So you can see that the paper industry it involves many steps like this one. This is the for the pulping process. We have option that we can use, which is on the with stock, or we can use soda process, which is mainly based on the sugarcane bagasse as the feedstock. And after we get pulp, we use the pulp for the pulping process. And pulp is the main the cellulose. Cellulose we used to use any chemical product, like in this case we consider ethanol, we consider nick, and somehow we go to the list and okay, but for ethanol also, it's not quite so we use one superstructure. Also the pulping process, you also get back liquor. The back liquor is lignin. The conventional process, they use lignin as the energy resource for the process. As I showed you earlier, that it can be used to produce valuable chemical. In this study, we consider to include the EE production, the lignin to syngas, use syngas to valuable maybe the ether, or an extract and as just sell it as a lignin. This is also another possible product we consider. This is the super or this is some and that we can draw the super stack eucalyptus, sugarcane for the material, and they involve the filtering process different, and also helping biorefinery filtering and for the chemical, and somehow this is the diagram, but there are details like red in more detail like this. It involves another hydrolysis reaction, separation possible. So those kind of individual steps we include, and we can in soup to show you an idea that when we get all those information, as I told you earlier, that for the first step, the synthesis, it involves the superstructure generation. Second step is the superstructure. So this one with some assumption, we propose that okay, we consider 100 raw material for the production line specific the cost material product and whatsoever. We need to specify the object, and in this study we consider maximize the take to account sale and cost of raw material, chemical added, whatsoever. This one is the scam by the for two scenarios. This the scenario that our paper is also one possible product compared to the possible product in the succinic lactic acid or as earlier. The case is the case that we still need to operate the paper as for the paper production. So this is to show that we and to the best solution. And this is the reason the calculation after we get the optimization. We found that the best way is to produce succinic acid. And for the should be the case, but as the feedstock to start process in order to get the product as the succinic acid. And some of the applicants should be DME and electricity. And on the calculation profit of 67 million US dollar per year. And if we compare the start process with the paper, we can get the profit of only US dollar per year. You can see possible of the profit of about 6 US dollar per year is quite significant. So this one we also consider that somehow we would like to do the comparison. Conventional, we get the profit like this, and if the demand to the final 67 million US dollar, but this one you don't need to think at all. But from the purpose for the paper production, but where we are involved with simulation, we can put our sometimes if the market doesn't go to the succinic, maybe we can go to some other valuable chemical product. We specify as a possible product, and we can get the possible product estimated about 6 US dollar. So it's still higher, but less than use the succinic acid. In the reality, if succinic acid is not of interest, so we can do others. The same with some another potential product. So the profit become negative. So it shows that it's not a good way to select and convert per industry. Your industry will make it because somehow the profit go down. So this is the way that we can calculate, and as earlier calculation can find that is based on process. So you can calculate, and you can see the best option to the succinic profit is about some low than use the process. Okay, so if we conventional pulping process, the profit is about $10. So you can see it integrate the concept of final in the $47 million increase. This is to go to second scenario that we still need paper to supply the demand of the paper. So still need paper. So we use the best case based on the soda process success, and then in the scenario that for the pulp for making paper, select the best solution, and the say 50%, 100%. You can the calculation. This is the 20% pulp split to paper product. It's still okay. And this is for the 50%. So what US dollar benefit for 80%, the way that so with the calculation, I can show you that there are possible implication of biorefinery and the paper industry. So we can go to the next. This is that we get the solution from the our calculation, or with the we can go in detail for the and the process that we process process and of the lignin EME something like this. So we can go into the individual process, make the simulation. It's something example that is that we need to involve the idea. We need to go to this step, like this, and then some reaction from the in order to get to some product. And also, this is some step that involve the Suttichai acid fermentation, also the place as well with the so something like this. So get a lot of information that is but can be used later for some other project as well. So this is the step for the mass simplification. So there are many processing as well. We go to the analysis. After we get to the Nicholas equation, so we can find the measure what for the area that we prove in order to get better process, better operation, better technology, when the profit we have able to process and that we also economic of economy as well, and some other information like the CO2 emission, the global warming. They involve the negative CO2 emission in different technology. So this one we can identify the I mentioned to you earlier that for this process, for test with the solution we achieve the action the so helping view. So the is the high demand of electricity. This is the use of fuel as the resource. So to improve technology to reduce the demand of electricity or by some green route to get the green for the process. Second process that we did for the get Suttichai how something like this. We find that the major problem is on the CO2 emission from the process. So one the next step of the emission can be proposed. So, my student proposed why buy some energy alternative of the electricity generation. And for gas, for the high emission of CO2, not to utilize to produce some more useful emissions as well. So
Recording stopped.
to make more DFT product.
Recording in progress.
Solar as alternative to the first project that we need to reduce the demand of the electricity and use the energy of solar roof or solar cell that can be used right now, and I think it's much cheaper. So this is she proposed. The second product for the CO2 emission, something quite serious. So we can try to reduce emission by further utilize it by just it like and to make it and then to make the gas something like this. So this proposed process for generally we analysis and the analysis with something like this. This is we call a data chart that take into like the profit CO2 emission, cell production, something like that, and we comparison to be the best case process, any other alternative, and okay, if we can say profit with less energy consumption, less CO2 emission. So this is criteria that usually we apply tools in order to select the based on our like. So this is the way to show you an example for utilization of process system engineering. Implement it for the industry. I'm sure that with the same approach, the methodology is possible to apply in some industry success. The current project that we are right palm oil industry. We can see that for the industry, it involves, for example, for the biodiesel product, involve palm oil production for the and all that oil tree, and that we are working on is try to integrate all together and to try to find the possible and possible processing possible from the different steps you earlier that this is how and it involves a number of, as I told you, so it can be useful for the process or system like the production of succinic acid. You can see oil industry, it also involves the biomass and to make succinic acid, lactic acid. You can use this for the calculation. So get more and more data, you can cover some other industry as well. And this is to show you that if you are interested in more the work that I mentioned to you earlier, you can go to the this journal, Computer and Chemical Engineering. This is the first work that we on indication of set for the development of sustainable process for power and paper industry, and for the other one on the process development sustainable biorefinery system indicate the existing helping process, which in the Journal of Cleaner Production. I think we come to the final end of my presentation. I would like to acknowledge all the sponsor, see collaborator from different guiding agency. Also, I would like for making it possible. Okay, thank you very much for all your attention. I think I still have about 10 minutes. If you
Yes. Professor Suttichai, thank you so much. Really, thank you so much for that very interesting presentation. Although we have some technical problems with, probably due to bad internet connection, and the voice was a little bit choppy, but I think the students can follow from the slides. Professor Suttichai, like, very amazing, really very interesting presentation. And I learned a lot from your talk, especially how you make this the slides, very clear slides, actually. So I really learned a lot. Not only the topic,
I would like to
not only very
to acknowledge my yeah.
Oh really? Yeah.
Help
The
me
topic.
prepare the PowerPoint. Yeah.
Mm-hmm.
And as I mentioned to you that my background is physics and reaction engineering, but somehow I get involved with the is very important.
I see.
Would make some good decision which way should we go in order to make it profitable and taking into account of any other aspect like the environmental, global warming, safety, and operation health, something like that. So this is very important. That's why I try to shift a little bit to this area so that we can select the right product, right process, and develop project for getting more grant. Okay.
Yes, professors, really very interesting and timely nowadays, especially that, all of the nations, all right, worldwide are considering this climate change, and your approach would be really very useful in tackling these issues about climate change. Let us listen to our students. Students, do you have questions? It is really a very rare opportunity to have Professor Suttichai with us. So please ask any questions that you may have.
Or if possible, if you have some other cases in your theory, that would be interesting.
Yeah.
One representative maybe from India to the development, particularly on the palm oil industry. I think that's gonna be very important as we top palm oil in producer in the
Right.
anyone share.
Yeah. Or you can use, if you want, you can use your chat function. You can also raise your question using chat if you like. All right. Okay, let's listen to Dr. Ian Dominic. Please go ahead, Dr. Ian. Okay.
Hoping that this
Nice to
internet
meet you.
connection is stable. So yeah, thank you, Professor Suttichai. I don't have any questions, but I can comment on the work. It's really useful at this time. What I can say, even now I'm having connections with our Department of Science and Technology. We haven't really looked that far. What I can say is we can really use the model that you established, looking at the superstructure on how we replace the products with the bio-based products that we produce from the bioprocesses. Yeah, I think we can, we can follow your footsteps on this one. Because the state of the Philippine biorefinery is that we're focusing now on biofuels. That's the first generation product of the biorefinery. So we're still in the dark in biofuels for now. But definitely, this is a really good presentation. I'm really glad that I attended this session. Thanks so much. And to Prof. Kitain, thank you for inviting me. Thank you.
Thank you very much. I think even we have done work in real implementation by the government. I think it's still difficult. But the sure, I think should be a good alternative. And if we to gear development in this direction, it should be okay for our country, something like this. But lots of work to do. And I personally quite with the PSD side, process system side. They try to develop tools very useful and convenient for us. It. Otherwise, if we make the hand calculation Excel or something like that, it's possible to make happen in short strength.
Yeah.
It's very
Thank
important. Thank you.
Thank you very much, Professor.
Thank you very much, Dr. Ian Dominic, for your comments. Yeah, indeed, Professor Suttichai, it's really very useful tool. And thank you for sharing your work to us today. Any comments or questions from our students? Dr. Siti, would you like to ask someone from ITS to ask questions to our? It's really a very rare opportunity to have with us Professor Suttichai. Yeah.
Okay, thank you, Professor. I think what Professor Suttichai explained before is really interesting and then really close related with our student work currently, because currently some student work on biomass utilization to make intermediate products. So maybe some of you can raise some questions. Marcel, Eva, Hinda, Rian, maybe you can raise some questions. Marcel, are you there?
Yes, Ibu.
Yes.
Okay.
Okay, sorry, for the moment I cannot on my camera for the moment. Sorry for that. Actually, there is no question, but I would like to thank Professor for the presentation. It was really interesting. Thank you very much, sir.
All right.
Professor
Can you share me a little about the development about the oil industry in Indonesia? So what is the direction?
Okay. Currently, we have soft loan from ADB to develop science and technology park, STP, science and technology park. And then one cluster is talking about the biomass utilization.
Yeah.
So we have to make like a mini plan and also a teaching industry, something like that, using biomass. We have so many kind of biomass, for example, like from palm and also from coconut coir, something like that. And then we have to fractionate it into intermediate products such as cellulose, hemicellulose, and lignin. If we can recover cellulose, lignose, hemicellulose, and lignin, we can process further, for example, as a paper and pulp industry, etc. Yes, so that's why it's very, very related, and this is very rare opportunity because the 4 students I mentioned before, they are in team to make that mini plan.
But how about the oleochemical industry in Indonesia?
Not yet there, Professor. We still how to recover cellulose, hemicellulose, and lignin as much as we can. So after that, we will proceed further.
Okay.
In Thailand for the palm oil, so try to forward to some not only resale. They want to do things renewable such as try to make palm oil for doing making exchange deal using them at a specific, I mean, melting point or something like that. So they need to and fractionate and develop it as exchange something like this. Some industry they feel that they can import or export other country. So this is some development, and in Thailand they are considering more opportunity for using palm oil to other products. And
yes.
To go, but we are working on it.
Thank you so much. So we have to discuss further, Professor Suttichai. As mentioned by Dr. Dominic also, right? So we can use your superstructure model to develop later on.
Yeah, thank you.
Any questions? Any other questions or comments from our students, especially from our students? How about from Kumamoto University student? You may ask question using chat if you like. Well, I would like to mention once again, we're very sorry about the technical problems that we had, probably due to this very bad internet connections, but I hope you understand it from these slides. Questions, everybody? No? Okay. Well, if you don't have any more questions or comments, let us thank once again Professor Suttichai Assabumrungrat of Chulalongkorn University for sharing to us his expertise on process systems engineering for the development of biocircular green economy, the BCG. Thank you once again, Professor Suttichai.
Thank you very much.
And we will continue. We will continue this collaboration, Professor Suttichai. Thank you so much. And to our students, all right, let me remind the students of perspectives on biomass utilization that you will have your presentation next week together with your colleagues, or I should say friends from ITS. So please submit your presentation slides by the 25th. In the case of Kumamoto University students using Moodle, and for ITS students using My Classroom, right?
Yes.
And also, of course, do not forget to submit also your reports. All right. So thank you very much, everybody. Thank you for joining this lecture of Professor Suttichai. Thank you so much.
Thank you.
We will have a 5-minute break. And then from now, after 5 minutes, we will start with this one. Okay, let me share this. From 2:30, I will have a very brief lecture introducing our EASA project and how this project contributes to the attainment of sustainable development goals. And after that, you will have a roundtable discussion. You will be separated into 4 groups. You will talk with other participants of this Sakura Science Program. And then after about 30 minutes, you will go back to the main room and then share to everybody the summary of what you have discussed. All right. So that's it for today. I will see you again later for the Sakura Science participants. Professor Suttichai, thank you so much once again. Bye-bye.
Thank you.
Recording stopped.
Hello, once again, everybody. Can you hear me? Hello. Can you hear me, everybody?
Yes,
Yes. Okay. All right. Thank you. Is the connection okay? Thank you so much. All right. So let me introduce to you how our project on algal biomass could contribute to the attainment of sustainable development goals by 2030. I'm Armando Kitain from the Center for International Education here at Kumamoto University. So my talk will be divided into days 1, 2, 3, 4, 5, 6. I'm going to introduce to you our eAsia project on alternative energy and our approach to the conversion of algae or microalgae into useful chemicals and biofuels. One is the use of microwave carbocatalysis. The other one is the mixed carbon dioxide and water system. Then I'm going to summarize it. I will show to you the challenges and outlook and how we also educate our future Japan ASEAN STI leaders. This is actually part of this eAsia project. Our eAsia project is entitled Development of Algal Bioenergy Systems for Green and Sustainable ASEAN Region. And this is in collaboration with Professor Suttichai of Chulalongkorn University, ITS with the team of Dr. Siti Solaika, the De La Salle University, the University of Technology Petronas, and the Bacoa University of Vietnam, and also from Myanmar. So algal bioenergy system for green, sustainable ASEAN region. This is a multidisciplinary project, and we would like to convert algal biomass as feedstocks into useful biochemicals, bioenergy. I mentioned to you multidisciplinary. It consists of this team from various regions of Southeast Asia. Thailand is in charge of ultrasonic biofunctional catalysis and also kinetics, because Professor Suttichai, as you learned from his lecture just a while ago, is into computation, process systems, the use of Assabumrungrat plus and so on, and evaluation of kinetics and the mechanism. The Philippines is into life cycle assessment, LCA, and also mathematical modeling. ITS, with Dr. Siti as the leader of the group, is into algal culture and cultivation, and also the utilization of the feedstock algae using mixed carbon dioxide and water. So hydrothermal liquefaction. Vietnam is also contributing their expertise on algal culture. Malaysia also on bio-oil and biodiesel production and the evaluation of the properties of biofuels. And Japan, our team here is focusing on the use of green technologies, like the use of microwave and carbon dioxide and CO2. So this is one way actually on how we can like use or convert carbon dioxide from a liability into an asset. So CO2 is a liability now because it is contributing to global warming or climate change. But we would like to utilize carbon dioxide and utilize it as a solvent and also as a chemical to enhance chemical reaction. So this is the theme of this eAsia project. For Japan, it is headed by me and Professor Kida, Thailand Professor Suttichai, the Philippines, Professor Raymond Tan, and also Professor Aviso, Joseph Ursenia, Indonesia, Dr. Siti, co-collaborators from Malaysia, Professor Susana Yusuf, and from Myanmar, Professor Wayne O, and from Vietnam, Dr. Phong Ha. With regards to the technology, one is microwave carbocatalysis. Well, this is how we can contribute to the sustainable development goals using clean energy in the form of microwave and also developing products that can be considered as or biofuels or bioenergy. So look at this. This is actually the significance of the synergy of microwave carbocatalysis. If you look at this, you can see bubbles forming, right? That is when you irradiate microwave for only 0.5 seconds, and it's off for 4.5 seconds. So you have the carbon here. The temperature is monitoring the thermocouple is monitoring the temperature of the solvent. The solvent is decaying with a boiling point of 174 degrees centigrade. I interpret this video as this: when you irradiate microwave, instantaneously the surface of the carbon will reach the boiling point of the solvent, which is decaying, 174 degrees centigrade. This is evidence from the formation of bubbles. So the temperature on the surface reaching the boiling point of decaying at 174 degrees centigrade, that's how rapid microwave heating is. Now, selective and internal. Let me explain to you what we mean by selective and internal heating. Look at this. This is after 2 minutes of microwave irradiation, pulse microwave irradiation. The bulk temperature, the solvent, reached only 70 degrees centigrade. While the surface of the carbon reached 174 degrees centigrade instantaneously, the solvent reached only 70 degrees centigrade after about 2 minutes. That's how selective, internal, and rapid microwave heating is. And this is really amazing in combination. I mean, this synergy of microwave carbocatalysis is really amazing. Now, talking about carbon material, we are particularly working on graphene oxide. Somehow, the use of graphene oxide, which is also a catalyst or material that can be derived from biomass, can help contribute to SDG number 13, climate action. So I think it was mentioned in some of the lectures here that the use of carbon char. This is one example of carbon material. Can make the process zero emission, even not zero emission process. It's more zero negative, all right? Negative emission process. So instead of like, it's even advantageous of using this kind of carbon materials that we can derive from biomass. Okay, so graphene oxide, we have so many functionalities on the surface of graphene oxide, and we would like to utilize these functionalities in combination with microwave. And the synergy of microwave and surface functionalized carbon-based catalyst can really significantly accelerate any reaction. And for this, we apply this to the synthesis of biofuels from waste oil. Again, this will connect to SDG number 7, affordable and clean energy. From waste cooking oil containing free fatty acids, triglycerides, by esterification and transesterification, we can get biodiesel fuel. The byproduct, the glycerol, we can convert it further into a chemical we call glycerol tert butyl ether. And GTBE can be added to biodiesel in order to increase the cetane number. The cetane number will boost or enhance the property of biodiesel. It's like adding octane enhancer to gasoline, all right? Increasing the octane number of gasoline will avoid this knocking. Okay? So it's like anti-knock. It has an anti-knock property. So that's what we are currently working with, converting glycerol with into GTBE. We are thinking that in the future, we can add GTBE to biodiesel in order to increase or enhance the fuel property. Okay, this is, if you are interested with regards to the mechanism, reaction mechanism on the graphene oxide surface, you may want to access this article published in ACS Energy and Fuels. We are also into development of biofunctional catalysts like bentonite, a clay, in combination with graphene oxide. So bentonite serves as a base catalyst, while graphene oxide serves as an acid catalyst. And the combination of these base and acid catalysts can do both the esterification and transesterification simultaneously. Thus, well, if you have the fatty acid in your sample, free fatty acid, and the triglyceride, using these catalysts, biofunctional catalysts, you can directly convert those free fatty acid and triglyceride into biodiesel fuel. And this is based on the work of one of our short-term exchange student from UTP. You got a free fatty acid conversion of 89.5% and the biodiesel yield of 98.5%. So many applications like this one, we did this conversion of microalgae oil that we can derive from microalgae into biodiesel as well using the same biofunctional catalysts. Other than that, we are also trying to convert cellulose into more fermentable sugar, the glucose. Very difficult to ferment the glucose because it's a polymer. One, it cannot be easily dissolved in water because of the crystalline property. But if you can like convert it into glucose, it can be easily fermented. So that's what we did using graphene oxide. The good thing with graphene oxide, it has a very high adsorptive capacity of cellulose. If you may ask, graphene oxide again is derived from graphite. Your graphite is this lead from pencil. You use the pencil in order to write, right? And the paper is cellulose. Using graphite, you write on the pencil. This shows the adsorptivity of graphene material on the surface of cellulose. So we capitalize on that, especially the adsorptive capacity of cellulose on the graphene oxide surface. And we were able to obtain glucose in 1 hour using a temperature close to about 200 degrees centigrade using the synergy of synergy of graphene oxide and microwave irradiation. Other than that, we are working on the synergy of carbon dioxide and water. All right, synergy of carbon dioxide and water. I will explain this later. The synergy of carbon dioxide and water actually will give you an acidic condition, which is important in catalyzing reactions such as those involving biomass. You need this environment or condition in order to break those cellulose, those polymers into monomers or more fermentable sugars. That is one example, but there are a lot of possible applications of this CO2, water, and synergy. The good thing is we can apply this at a relatively lower temperature range, close to about 200 to 300 degrees centigrade. Okay, so well, I don't want to explain the details of why we are working on microalgae or algal biomass. So we are applying the concept, the technology that I introduced to you. One, for example, is the conversion of fucoidan. This is similar to cellulose, but this is a polymer that you can get from seaweeds, right? Fucoidan, polysaccharide. You also convert this into fucose, also using the synergy of microwave and carbocatalysis. So this is the mechanism. If you are interested, you can go into the details of these mechanism by referring to our paper published in RSC Advances. Other than those technologies that we are developing, we also are contributing to the cultivation of future Japan-ASEAN science and technology innovation leaders. And this is one of the reasons why you are here joining this Sakura Science Program. This is important, all right? Really important to cultivate these future Japan-ASEAN STA leaders. And we have these activities. The purpose, again, quality education. We had, you witnessed perspective on biomass utilization, the lecture of Professor Suttichai. If we do it face-to-face, we'll have this kind of classroom, a mixture of Japanese students and international students talking about this topic, biomass utilization, multidisciplinarily. And this is what we mean by quality education. And the lecturer here is Professor Susana Yusuf from UTP. Professor Yusuf is at the back listening to the presentation of the students. We consider this as student classroom center, student-centered classroom. All right. So there you are. But now, before we had those global teaching, but we collaborate with ITS. Dr. Suttichai and Professor Maria to have this global team teaching in combination with collaborative online international learning. This started last year. And thank you very much to Dr. City of ITS and Professor Maria for making this happen. A combination of global team teaching and a coil. This is quite unique in this education. And this, again, will contribute to SDGs, all right? Sustainable Development Goal number 4, quality education. These are some of the photos of perspectives on biomass utilization last year. Okay. Participated by more than 180 students. Sakura Science Exchange Programs. I also mentioned to you that one of the reasons why you are here joining the Sakura Science Exchange Programs is to develop future Japan ASEAN science and technology innovation leaders. And this is also one way in how we can contribute to sustainable development goals of United Nations. This was in 2019, but actually this Sakura Science Program started 2014, year 2014. And every year, almost every year, we have this Sakura Science Exchange Program. So from 2014, now it's 2021. So I think you are the ninth batch of this Sakura Science Exchange. Well, last year we cannot do face-to-face or offline Sakura Science. So we did online Sakura Science Program last year. It was participated also by your universities, similar participating universities. These are some of the photos as well during the discussion. You will also have a discussion later. All right. Then, well, you cannot visit our laboratory, but we posted some photos on how we do experiments in KIDA laboratory. You cannot also visit IROS, but we also posted an introduction of IROS. So again, if you haven't seen the video yet, please access our Facebook group account. You can still see the videos. Okay. So, well, using these approaches, using our technologies, our goal is to contribute to this green, sustainable Earth by utilizing green technologies. And for now, we are focusing on algal biomass. But this is not, the feedstocks are not only algal biomass. We can also tap other feedstocks or biomaterials like the palm oil, all right? Or oil palm residues. Professor Suttichai also mentioned about that, tapping oil palm residues as feedstock for development of chemicals in a biorefinery. So using our technologies, our goal is to contribute to this green, sustainable Earth by using algal biomass. We, the team of this eAsia project, together with Dr. City and other partner universities, we envision a robust algal biomass industry in the region as a model for other parts of Southeast Asia and the globe. Thank you very much for your attention. I would like to acknowledge, of course, our partner universities, our team, the member of our team, global team, and also the funding institution, including JST, eAsia, Kakenghi, Justip, Sakura Science, of course, and the students from KIDA Laboratory. Without the students, these things won't happen. All right. So thank you very much. Okay. This is what we are going to do after that very brief lecture. This will be the topic for discussion today. You will talk for 30 minutes with your group mates. You will talk about how Sakura Science Exchange Program and the activities, of course. Also biomass utilization, because that's our topic for this week, biomass utilization, although multidisciplinary aspects of biomass utilization can support the attainment of sustainable development goals by 2030. After the discussion, a representative from each group will report a summary to all participants in about 3 to 5 minutes. All right? So let me stop sharing this one. I hope you know already your group. Right, where is it? I'm sorry. Do you know your group already? I hope you know your group. All right. Okay. Again, let me stop sharing this one. This time, let's listen to the facilitator, Sure. Would you like to say something first before I divide them into 4 groups? Sure, please.
Yeah, sure. Well, hello, everyone. Can you hear me? Yes. Okay. So, hello, everyone. My name is Cynthia Sorelli Castrisasi, but you can just call me Sore. It's way easier to remember. So, for the activity of the round table, I will suggest, if possible, if you can summarize your points into 3 like bullets, so it will be easier to present them. It could be 1 to 3. And if you want to select one of the goals and then work on that, that's also okay. If you want to work in different goals, it's also okay. And of course, if someone already mentioned one of the goals and like, you don't want to say the same thing, then you can just work into it, build a little bit more about it. No problem at all. So, well, let's everyone share our knowledge and also like ask a lot of questions regarding the biomass utilization. And also maybe you can say some of your experiences while working in your own research. So yeah, I think that will be all. Thank you.
All right, Sure, thank you so much for that. So later on, Sure will also facilitate the discussion. All right. So, well, let me share to you again your grouping, just in case you forgot your group number. There you are. I hope I'm sharing the right. This will be your group number, all right? So group number 1 consisting of Sure and other members. Group number 2, Gina, and so on. Group number 3, Takeshi Shinkai, and so on. Group number 4, Taiki, and so on, okay? So I am now going to open 4 rooms. So you have 30 minutes to discuss anything, all right? Discuss anything, make friends, discuss anything, and later on, you will go back to the main room to give a summary of what you have discussed. Go ahead, everybody. Join your room, please. And for those that are not in the list, you may want to join any group that any group of your choice. Okay, go ahead, please.
Kitani Sensei,
Ay,
I cannot join the my breakout room number 3.
all right. So I will move you to group number 3, okay?
Thank you.
Takeshi Shin. Yes. Assigned to your okay. Go ahead.
Yes, thank you very much.
And I'm working on the topic of biomass, the delignification side for paper pulping issues and stuffs. So yeah, that's all.
Okay, thank you.
Hi, I'm Kidarabo student. I'm B4. I I can speak English very well. So I study metal oxide for gas sensor. So I don't know biomass is I don't know biomass energy. So please help. Thank you.
All right. Who wants to go next? Or I'm just going to be pinpoint people.
Hi, my name
Hi.
is Dana Buchan, or you can call it Day. I'm a grade 11 student from Philippine Science High School. Yeah, for Philippines. Thank you.
Thank you. Right, let's go, people. We have 30 minutes.
Can I go next?
Yeah, sure.
My name is Miranda Amira Sulaiman. I am from the doctoral graduate from ITS Indonesia. Yeah.
Well, nice to meet you.
Nice to meet you too.
Okay. So we have Alicia also, but she cannot turn her microphone on. So she's also from the Philippine Science High School. Ooh, nice. Okay, well, if you have any comment or any question, just please put it in the chat. We can read the chat also, no problem at all. So who's next? Who wants to go next?
Hello, am I audible?
Hello.
Good day, everyone. My name is Janos Nathaniel Casbadillo. I am also a grade 11 student from Philippine Science High School, Western Visayas campus. And actually, this is my first time being immersed in studies relating to biomass. So I'm really glad to be a part of this. Thank you.
Welcome. Okay. Who else? Who else? Who hasn't speaking yet? Akman Rifki. So I'm guessing he cannot also turn on his microphone. Damn. Okay. What about Fikri? Lofty. Lotfi? Lotfi, I think. Okay, well, so I guess we're just going to work with the ones who can speak and hear, I guess. So let us begin because we only have 30 minutes to discuss about this. So is someone here in this group actually working with biomass? Or like has the idea or a research topic?
Currently, I'm working with biomass. Yeah, mostly the first generation of biomass. But our topic is now, so we are going to tackle two questions, is it? The first one and the second one, right?
Yes, well, one is about Sakura Science and how the biomass utilization is working towards the achievement of the SDGs.
So which one shall we tackle first?
Well, I think this is the first time for everyone to join Sakura Science. So what's your opinion about Sakura Science program? What have you learned and how do you think it's actually working towards those, to achieve those goals?
Right, if that's the case, I'll go first.
Go.
What I felt about this program for the past activities, actually, it gives us some input where that input actually only focuses on global part, which is focusing on global part, which actually it broadens the knowledge because different countries have actually the different biomass utilization. So in that we can actually the prospect actually is broadened. So I believe in this kind of discussion and also educational talk, this will actually help to create more better idea and more sustainable ideas. I think that's for me.
Okay, it's a really nice one. Who else has an opinion about the Sakura Science program? I know this is your first program and maybe a little bit too overwhelming for now, but yeah, please give your input.
I agree with Vineyard that with this program, we can, from another country, we have a different different subject to discuss, and then we get the knowledge from other country as well.
Does someone else has something to say? Because actually, I think if this were to be a in-person program, I mean, if we could have made that way, and you come here to Japan, you will meet also people from the other countries, like face by face, and you will see how maybe sometimes we have the same idea, but we execute it differently. We have the same objective, but we have different processes or different ideas on how to work on it. So I think that actually goes to the quality education goal in how they give us perspective into how other countries are working towards them. Someone else wants to say something? Don't be afraid. There is no wrong answer.
Can I share something?
Sure.
I think that the Sakura program is very significant as it gives different countries a platform to share their insight and their knowledge regarding biomass utilization. And I think that's very important considering our current time and age wherein we need to find alternatives that are healthy and safe for the environment. And with this program, I think this interchange of knowledge is very useful and very significant. Thank you.
Thank you. Thank you for sharing. Does someone want? If you cannot speak or you cannot put your video camera on, it's also okay. You can also write in the chat. We can read also that part. You can interrupt or just write down. It's no problem at all. Well, I guess the first one we have talked about already, how this program actually affects not only our view of our own country, but also, excuse me, but also how we can develop new industries and new points of view. Yeah, basically that would be, I think, the main point of the Sakura Science. So, well, I think we can move to the second one actually. How biomass utilization is working towards the achievement of those goals. Well, I'll try to go first then. So I think since different countries have different types of biomass, and then sometimes they don't have the same technology at first, while going to other countries, they may have also the opportunity to practice with that kind of technology and then go back home and then introduce it to their own country. So I think that is one of the points of the biomass utilizations, to make partnerships for the goals, for this specific goal, for the biomass utilization and others. Who wants to go next? Don't be scared. There is no wrong answer. You can also write. That's also no problem at all.
Sorry, can I add?
Yeah, sure.
Okay, I feel that another part, the biomass utilization comes into part where actually everyone, we are looking, because since most of us are in the science in looking thing, we actually also forgot about one thing, which is actually is biomass utilization can also helps in the SDG 2, which is zero hunger, in where the small support scale producer, for example, they all linked with this kind of energy crop or agriculture residue. The revenue from crop actually often boost incomes and increase the productivity of small scale fawn producer, but there is like trade-off between the revenues from residues, which costs actually maybe that part untapped yet. So I feel that maybe the zero hunger part can be solved by biomass utilization.
Yeah, you're right. As it could become a new industry and really well-maintained industry, will also help giving jobs.
Yeah.
And also help with the utilization of the current waste that we have, that it's just making more space instead of doing any good.
Yeah.
So yeah, the utilization of that one can also be helpful towards that. Pretty nice point. Someone else?
Since biomass is since energy is made from animals and plants, so there is little garbage and it can be recycled, so we can achieve to SDGs or sustainable cities and communities, saving fossil resources, I think.
That's a good point. Someone else? Miranda, Janos, please help.
As for me, I haven't done my research yet, so I don't know about the biomass utilization in the like what I'm focusing on. So I'm still researching about biomass utilization. Yes.
Yeah, I think a lot of people in this group and in all the Sakura Science program, some of them, this is the first time actually hear about the biomass utilization and everything, and it's like, whoa, can that be done? Does actually exist? So yeah, it's overwhelming, to be honest. But quite an interesting topic, biomass utilization. Mhm. What about Janus? Do you have any opinion about that?
I think that in the Philippines there are a lot of resources that can be used that can be utilized for biomass, and I think that with this program, student researchers like us can be exposed to these knowledges, and we can share these to Filipino people who are not yet well versed in topics like these. And I think that's such a good opportunity because not only does it provide like alternative fuel, but it can be used as sort of like an income generator, which can help them. And I think that's a really beautiful insight that can be taken from this.
That's a good point. Someone else wants to participate? We still have 14 minutes. Well, kita Sensei, you say 15 minutes, so plus 1 minute. If you have any question also, you can go ahead. Oh, okay. We have one text. Okay. From my perspective, biomass utilization could indeed help in terms of sustainable development, specifically for the SDG 12, because it can be a means for improving resource use efficiency while reducing the need for fossil fuel extraction. Also, here in the Philippines, biomass can be further utilized to provide energy, power for marginalized areas without access to electricity. Wow, that's a really good, nice point. Yeah, yeah. Really nice point, Alicia. Thank you for that input. Okay, someone else? You can also ask questions about the research if you have any question about how here is in Japan, and anything goes. It's okay. If you have any question.
Sorry, are you working on the Kita laboratory or?
That's a difficult question. Yes and no, because my laboratory was actually together with Kita laboratory. So we just recently separated. We parted, but still, since when I entered here, I was a student of Kita laboratory. I'm still collaborating with the students. So you can say basically yes, 50% yes. Yeah. Any other questions you may have? Anything goes, everything is okay. Is someone interested in coming here to Japan, by the way?
I think the border is closed or not. The Japan border. Is closed or open right now?
Yeah, I think there, in this point, I think there have been about 15 students who actually enroll here in the Kumamoto University, but haven't been able to come here to Japan. They already enrolled, but since the borders are closed and some other situations in our own countries, I think, they haven't been able to come here. But they are taking classes by online in some cases. But yeah, the situation is difficult. We're really hoping that by next year, a lot of people can come in already. Okay, so will someone here in this group want to be the one who exposed after 30 minutes? Is someone interested in that? To be the star of the group? mean, I can do it, but I would love having someone who wants to do it. Are you talking, Vienot Segar? Are you? So Vienot Segar is it no, right? He just disappeared, or is it? I don't hear.
No, 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 no. I'm
There.
here.
Did you disappear? What happened to you?
No, no.
Hello. So is someone, I mean, does someone here wants to be the one who presents after the 30 minutes, or you prefer just to be the listener? I mean, whichever is fine.
Sorry, you'll be presenting, right? No.
I mean, I can.
Okay.
I don't have problem with that, but if someone wants to be the star of the group and say, no, I want to, that's also okay.
I think all of us in the motion of we are fine with everything.
Okay. Okay. I guess that's also good. So yeah, I mean, again, any questions you may have, we're very much willing to answer it, either if it is for our research or just coming here or for our own countries, also okay. We have also a Japanese here, so he can also share his opinion.
How's the experience in Kumamoto University? Anyone from that university?
As an international student, has been really nice. Has been really fun. Right, unfortunately, right now we're not so many international students, so that kind of makes you feel a little bit lonely. But besides that, everyone here is really helpful, is really kind. They will always try to, if they cannot be the ones to help you, then they will find someone who can actually help you resolve your problem. They really support you with oral research. So yeah, it has been a blast, to be honest. I've been here for master course, and I'm here in my PhD, and I think if when I completed my master, I didn't like it here, I wouldn't be here for my doctor. So it's been really nice.
That's great.
Yeah, please come to Japan. It's fun. It's fun.
So really, you know anyone by Farhan Hakim? He sends his regards to you.
Ah, thank you. Me too. Please tell him. I hope he's okay.
Yeah, so far it's fine. Both of us are actually in the midst of completing our masters. Yeah.
I see. Well, yeah, I'll send regards to him, please. Yeah. We have 10 more minutes. 7 actually, or 8, depends on kita intense, but yeah. We have almost from 8 to 10 minutes. So how's the situation in your countries right now about the pandemic and everything going around, also in universities? Are you still having classes online, or have you started already being in person?
For Malaysia, I guess due for the postgrads, they are actually allowing to do the research. But for the undergrads, they are not so. So they are still stick with the online classes. While the masters and PhD student will go to and fro to the lab in order to complete their research. But with the what is that? What you call very strict standard operating procedure that the university implemented.
Yeah, I think the universities in all the world actually working towards doing something about this, how to make it a little bit more comfortable for everyone to go again to classes, because we need to graduate people. We need to do something. So yeah, it's good that they're also working towards that.
Yeah.
What about the Philippines from the high schoolers? Are you still having classes like online, in person?
We still have online classes as of now because as of the moment, our country is working in boosting the herd immunity with the vaccinations. And I think it is the best option as of the moment because we can't really risk the population for education, and still health is our top priority as of the moment. Thank you.
Thank you. Thank you for sharing. Well, does someone else wants to share something?
Can I ask a question?
Yeah, sure.
How's your language in Japan, since Japan has its own language?
Ooh. um, actually, since I like Japanese culture and the Japanese language before coming here, so I started studying before coming here for 3 years, and then I came here. I still feel like I should have studied a little bit more. But when you're here, you will actually get to know more about the language, to practice it more because you don't have any other option. And also because they also improving their ways with English, facilitating our ways with more English, how you call it? Material also for buses, for everything. They also put in a lot of effort on that. For when people come here, they could be like move easily in the country and everything. So yeah, even if you cannot speak the language, it's still, yeah, you can still do it. You can still come and be okay with it. I don't know if you did hear me, because I think suddenly I couldn't hear your voice. I hope you did. Someone else has any question?
Excuse me, I would like
Yeah,
to
sure.
ask something.
Mhm.
How is it like doing research or just studying in Japan in general? Like, how is the learning environment? And
That's a good question. So basically, if you enter for masters, is basically you're on your own. I mean, you can ask everyone, and they will be very much willing to answer your questions and everything. But it's pretty self teach, basically more of that. Here, professors don't actually expect you to answer questions. They will ask, but still some will not say anything, and they just continue. Well, I think in almost all our countries, we are the ones who are like, yes, I know the answer, or yes, I'm going like that. So yeah, it's a little bit culture shock, but still, you have everything you need to study, and you have a lot of people to ask. So yeah, it shouldn't be that much of a problem.
thank you very much.
Welcome. I think we have 2 minutes, people. 2 minutes. Sorry. So, well, yeah, I guess that will be for our group. So when the time goes in, you can just go back to the main. Actually, yeah, how do we go back to the main one, actually? Do we just put leave room and then we will immediately lead us to our back room? Maybe.
I think once Prof. Armando like we cancel the breakout room, all of us will be automatically placed in the general room, I guess.
Yeah, maybe. Because I am not so in touch with Zoom, to be honest. I mostly don't use it. So. Okay. Yeah, it will be automatically. Our rooms will close about 1 minute. Please go back to the main room. There. So yeah, leave breakout room and then you will go back to the main room. Okay. See you there.
All right. So welcome back, everybody. Welcome back. I hope you had a active discussion in your room. So, Sure, would you like to facilitate the discussion?
Sure, as always. So,
all right, Sure, please.
yeah.
Go ahead.
So, okay, so for the group one, we have also participants from the high school and also from Malaysia. And well, we actually work with the first question with the Sakura Science Program, how it actually worked towards the achievement of the goals. And as I think everyone will agree actually with this one, I think everyone is going to have the same answer. It gave us a global part that we don't have normally in our own countries, that we are sometimes too much into our own research to actually know how the global environment is, how the researchers are actually advancing in other countries. And also it gives us perspective, how our research can actually be applied to other countries and how they can also develop it a little bit more because they have either different resources or different industries or processes that we haven't even think about it. That will be for the Sakura Science Program. And about the biomass processing, well, I think we can also agree that it goes also for the zero hunger, the quality education also, because some of us maybe we didn't know about biomass utilization before coming here. We actually came here and we was like, oh, biomass exists. This is what we can do with it. So we are not only learning about biomass utilization and about the concept itself, but how other countries are working towards actually processing it and how to develop industry and science around it. So we think, yeah, it works towards the quality education and the zero hunger and partnership for the goals, especially. Yeah, I think our group is basically on those lines.
Anybody from group number one who would like to add to what Sure has just mentioned?
Okay, since from the group
Yeah,
one,
go ahead, please. Yeah.
Thanks for actually for facilitating us this now. We had actually a great discussion about Kumamoto University and also our part. Okay, I believe that certain SDGs that are actually been like partnership, all is something very common. But I believe that something that the biomass utilization especially helps in the SDG 2, which is zero hunger. As part of SDG 2 goal on sustainable agriculture and food security, it is important actually to account on the shifts of diet, because we know that the global population will not only grow in size, but per capita incomes also happens in most developing nations and expected to grow in line with their economic growth. So the demand of the agriculture product is also expected to change away from the like cereal crops more to protein rich food like meat and dairy. So I feel that biomass utilization can actually help, I mean the innovation in the biomass utilization actually can help to curb whatever the issues we are facing that can help to sustain the SDG goal 2. Yeah, thank you Prof. Mandu and Press.
Thank you so much, Vina. Did I pronounce your name correctly, Vina?
Yes, yes.
All right. Okay, good. Thank you so much.
In our group, does someone wants to also give their opinion? Miranda?
I think all of the have been stated. So yeah, I think that's all.
Okay. From the high schoolers in our group, does someone want? Because I think there were some people who couldn't activate their microphone, so they will write in the chat.
I see.
So also, yeah, if you want to write in the chat, I can read it, no problem. Well, actually, we had one comment from Elisha. I think Elisha. So she really had a really good point when she said that from her perspective, biomass utilization could indeed help in terms of sustainable development specifically for the SDG 12, because it can be a means for improving resource use efficiency while reducing the need for fossil fuel extraction. Also, there in the Philippines, biomass can be further utilized to provide energy, power for marginalized areas without access to electricity. I think it was a really good point. It's a really nice one. Well, is there someone also from the group one wants to share something else? Okay, I think that will be for group one, Sensei.
So much, Sure. Okay, and group number one, thank you.
Yay.
This time, let's listen to group number two. So group number two, please.
So good afternoon, everyone. I was about to share our slides to my group mates, but it was already time for this session. So I would like to share a screen where I consolidated our ideas for this session.
Yeah.
So for group two, okay, we talk about the common agricultural waste we have in the Philippines. So the waste we have talked about are rice hull, rice straw, sugarcane bagasse, corn cob, coconut shells that are commonly the problem for utilization or for waste disposal. So these are the feedstocks that we want to utilize for biomass utilization. And then one of our group mates suggested that biomass research is essential. The development of biofuel should be focused on some research because this viable option within the transportation sector. This is because by not involving modification in the structure or in the means of transport as such, they can create ecological transport without the need for all existing fuel vehicles to be replaced by electric or hybrid vehicles, which will lead us to a society with clean energy, one of the sectors that most uses fossil fuels. So we also came up with the idea of a development of carbonizers. So carbonizers can convert feedstocks into biochar and also biofuel. And this carbonizer can also utilize the heat energy as a portable stoves that can be used for household activities. So the biochar, on the other hand, that is produced can be developed into nanofertilizers, where we can infuse this with nanoparticles that can enhance production of agricultural products such as rice grains for rice production. And on the other hand, in addition, it is also well studied that this biochar-based fertilizer can also, after giving off its nutrients, can also absorb greenhouse gases such as methane and carbon dioxides and nitrous oxides that is produced during rice production. Hence, these products can help in mitigating climate change. Yes. Thank you.
Thank you very much, Narisa, for summarizing what you've discussed in group number two. Anybody from group number two who would like to add to what Narisa has just presented a while ago? Anybody from group number two? No. All right. So thank you very much once again, Narisa. Okay.
Yes, sir.
Now let's proceed to group number three. Group number three.
Okay,
okay, good.
Group number three. Hello everyone. I'm Takeshi. So I'm sorry, I couldn't summarize our opinions, all of our opinions, because I'm not familiar with research with the biomass. So it was really difficult for me to summarize. But I want to someone to tell that our research about the biomass. So can you hear my voice? So I want you to share your research about the biomass first.
Please continue, sir.
Yes. Sensei, Ortega. I'm sorry, Mr. Ortega.
Hi everyone, can you hear me?
Yes. Can you share your the research about the biomass?
Sure. So, in our group we have a student here. Actually, she's not. Their research is not finished yet. They're still in conceptualization phase. So one of their topic focused on utilization of bagasse or the waste in sugar mill and use it as a sorbent for removal of oil. However, just a quick overview with that, since our area here in the Philippines, specifically in Western Visayas, because in our area, we do have a lot of sugar mills here, specifically in Negros Island. So actually, I can relate. I can really relate with what Mr. Professor Suttichai discussed earlier. With the process. So for the process in the sugar mill, they are also utilizing the biomass. So for the sugar mill, they are the practice here, the current practice. So there are a lot of waste from the sugar mill, like the bagasse and the molasses. So the bagasse, when we separate the juice and the molasses, it's like the liquid part after the sugar or the powder, like the solid sugar was separated. So the molasses will be used for so this is in partner with the sugar mill and the biodiesel plant. So the molasses will be used as a raw material for ethanol production, and at the same time the bagasse will be used as additional fuel for the plant itself. However, there's still room for improvements here. Like for the bagasse itself, instead of using that particularly as a fuel, as Professor Suttichai said earlier, we can still utilize a lot of materials from that. Like maybe we can still utilize more alcohol or other products from that. So I think that in that way, we can attain here for the SDG goal, for the Sustainable Development Goal for number 7, affordable and clean energy, because for ethanol, we can use that as a biodiesel or a biofuel. And also for SDG 9, infrastructure for the industry, since we are creating sustainable energy using the biomass. I think that's all.
Okay, thank you very much. So is there someone want to share the research about the biomass? How about Carrie? His research is very interesting, so I want him to share.
Hello. So,
Carrie, can you?
Hello. Yes. Is my audio okay? Okay. So
yes. Okay.
So what we were discussing about my research was that because as of now it's just trying to optimize yield of phycocyanin from the cyanobacteria. And it's not really we can't really find the perfect fit in one of the SDG, but in what we've concluded was that it may be nearest to maybe the sustainable aspect. It's also a green if after maybe being able to finalize what if the cyanobacteria can compete with the current commercial production, then it will also be able to studied for industrial scale production, which is a green factory, and it might be closest to sustainable production.
Thank you very much. So maybe can I just say that's all. Sorry.
All right. Okay, so thank you very much, Takeshi Shinkai of the KIDA Laboratory for facilitating this discussion together with group number 3 members. Okay, thank you once again. Mr. Takeshi Shinkai.
Thank you very much.
Takeshi Shinkai is doing doctoral studies, right? PhD on sensors, sensor-related topics.
Yes.
Okay. Thank you very much once again. We will proceed to group number 4. Representative or facilitator of group number 4. Anybody who would like to represent group number 4?
Yes.
All right, Maybell, please go ahead.
Yes. Good day, everyone. I would like to be the first to talk from group number 4. So as we've discussed earlier, one of through the things that we've learned through the Sakura Science Exchange Program, and the activities that we've learned through here is that biomass is any plant or animal material that can be used to produce energy. And one of the researches that that I personally and the others also agreed that is best introduced using biomass is the introduction of bioethanol and biofuels made from, for example, researches such as my elementary research before, which used seaweeds and seagrass as an alternative to rice crops, to crops as sources for bioethanol. So we believe that those help, researches like those help with obtaining or successfully reaching Sustainable Development Goals number 7, which refers to affordable and clean energy, because they produce less residue or less carbon residue, and also they may also help with the responsible consumption and production, because instead of using lands meant to be for crops, for food crops, we will be using seagrass or seaweeds, which occupy less land and which are mostly considered as waste. Therefore, this kind of research will impact our society and our world better in terms of those 2 sustainable development goals. I would also like to call upon these are all that I can contribute. I have contributed to our discussion. I would also like to call upon some of the members, specifically Ms. Shaira Tagalog and also Ms. Jitamas, for their opinions as well. Thank you.
Okay, so hi everyone. As mentioned by Mabel, our group actually focused on talking about how biomass, which specific SDGs are answered by the use of biomass. So for our discussion, we've pointed out 3 major SDG. So SDG 7, which is on clean energy, and 9 and 12 for industry innovations and responsible production and consumption. So I guess the main idea we've had in our talks was that it is important to like have researchers focus on the use of biomass because it will help on developing future-based processes and innovations that can actually balance out the needs of the people by producing specific products, and as well as the needs of the planet, in which we need to take care of it as much as we can. So that's all from me, I guess. So.
Okay, as all my friends talked to you before, I will tell that like innovation help us to develop like a new thing to replace the old one. As we are starting to use a renewable energy from biomass instead of coal or natural gas, and I think innovation, I mean like SDG 9 can help us to success the goal of sustainable. Yes, that's all for our group, or you have something to talk for? If not, okay, thank you so much.
I would also like to contribute to the discussion of Group 4. Using bioethanol and biofuels in general is very relevant and timely since we know that we are facing a problem on the possible depletion of our resources. So this is a very good alternative because we can really use our agricultural resources. We can ask for, we can collaborate, we can ask for resources from agricultural countries, and this will also highlight the need for more agricultural studies in we for more agricultural studies so this will also help farmers in general, and that is why this is a very good alternative aside from tackling SDGs 7, 9, and 12.
Is that all? Group number 4?
Yes, I was about to end na po.
Yes, go
That
ahead,
ends,
Madam. All right.
I was about to conclude that ends our presentation po. Thank you.
Group number 4, thank you so much. Okay, especially to Mabel, Shaira, Tagalog, Jitamas, and also Rika. So they are high school students with these brilliant minds. Okay. Well, anybody from the participants who would like to add to what we have just discussed about how this Sakura Science Exchange Program, biomass utilization can support the attainment of sustainable development goals. Yep. All right. So we are about to end, but before we end this Sakura Science Program this week, is it okay, Dr. Siti? Can we have some words from Dr. Siti? Yes, if it is all right.
Okay, thank you so much, Professor Chitain. So it reminds me in 2016 when I joined the Sakura Science Program. But at that time, we are all women. So it's very, very nice. So up to now, we still have focus. It's for example, with Prof. K, and then Dr. Cynthia, and some colleagues from Thailand, we still keep in touch up to now, and really helpful in the future. You can expand your how to say, your network. You can collaborate not only in the research but also in personal life. For example, you can ask something, whatever like that. So that's why in my how to say, in my testimonial, I say that this program indeed can make the globalization faster, something like that. So that's all maybe. Professor Kitai. Okay.
Yeah, Dr. Siti, thank you so much. And thank you also for preparing the testimonial videos.
Thank you.
We will, all right? So everybody, I really thank you all for participating this Sakura Science program this week. We will end this 1 week program today, but we're going to keep the FB, Facebook group account. Please continue exchanges, collaboration. As I have mentioned to you a while ago, we can never tell, probably after about 10 years or 15, 20 years, you will also have the same collaboration that we are currently doing together with Professor Suttichai, who I first met at Nagoya University more than 20 years ago, and also with Professor and Dr. Siti Salaika, who I met here at Kumamoto University during the Sakura Science program. So it really gives you an opportunity to collaborate, do exchanges in the future. So I think we built friendships here. Please continue this friendship that we built through this Sakura Science Exchange program. And the Facebook, again, this will continue. Hopefully by next year, we can have face-to-face, so you can also visit us here in Kumamoto University. So I will continue to apply for a budget to JST in order to support this Sakura Science Exchange program. But for now, let's end here. We will continue with these exchanges, all right? So that's all, everybody. That's all for today. That's all for this week. And hope to see you again. I'm going to send to you the certificate of participation via email, also through your supervisor. Okay, before I close this Zoom meeting, can we have a photo? Screenshot.
Thank you so much, Professor, for your effort.
No. To everybody also for joining this Sakura Science Program. And of course,
nice to meet you all.
the KIDA laboratory students and all the participants, thank you so much. Really, my gratitude for you for attending this Sakura Science program, and also to the KIDA laboratory students for also helping me organize this program. All right. So, shall we have a photo if it is okay to everybody? All right. Well, okay. So I think this one. Okay. So 1, 2, 3. One more. Let me save it first. All right. One more. One more. Sorry. Okay. One more. Right. Okay. So, thank you so much, everybody. Thank you once again. I will keep in touch. I will send you the certificates of participation in the Sakura Science Exchange Program of Kumamoto University. Thank you once again, everybody. Bye-bye. Let's keep in touch. Bye-bye.
Nice to meet you all. Thank you.
Bye-bye.
Bye-bye.
Thank you very much.
Thank you.
Thank you, everyone.
Thank you, Fritz. Bye-bye.
Thank you, Prof.
Thank you, Vina. Thank you so much. Really, thank you a lot.